Hello there, this is Miss Nakayama, and today's lesson is 4.4b, solving polynomial equations by factoring. So this is a short lesson. I'm just going to remind you of the difference between solving and factoring. Okay, and it goes along with my saying of if it starts with an expression, it ends with an expression. That was 4.4a. In 4.4b, it starts with an equation, it will end with an equation. So to begin with, one of the things we definitely want to remember is the zero product property that says if a times b equals 0, then a equals 0, or b equals 0, or both equal 0. Okay, that's how we solve it. That's why factoring is the key, but one side of your factoring, when you factor, this is a factored form, one side has to be 0 or else you can't continue. So a different formation of our factoring summary. Before it was just a straight up graphic, a little bit more of a flow chart. Always start off with the greatest common factor. Look for how many terms. Binomials, you could have squares, difference of two squares. You could have cubes, either the sum or the difference of cubes. This is our SOAP formula I talked about last time. You could also have, that's with two terms. Then you go to 3 terms, trinomials. Again, easiest if you recognize a PST, perfect square trinomial. If not, use your favorite method to factor it. We talked about guess and checking. And then, last but not least, other polynomials, 4 or 5 terms. If it's 4 terms, we did some grouping 2 and 2 and looking for a common factor. And this is what you have to look forward to, P over Q. But we'll get to that later. So our first example, x cubed plus 216 equals 0. Ding, ding, ding. 2 terms. It's either the sum, well, it's not a difference, can't be squares. So it's the sum of 2 perfect cubes. And that's going to be the cube root of each of those. Cube root of x cubed is x. Cube root of 216 is 6. So this is going to give me x plus 6. And to remind you, that was the cube root of each. And now I'm going to use this factor. And I'm going to square the first term, change the sign, square and multiply them together, and then square the last term. And I also told you that this second one is always prime. So I still have 2 factors equal to 0. So I set the first one equal to 0, x plus 6 equals 0. Now this second one, I think y'all have heard me say enough that if this is a 1 and that's even, it is the easiest to complete the square. So I'm going to set this up to complete the square, which means I got to move the 36 to the other side. And I've got my plus blank on both sides. And I take half of my b, half of my middle term, and I ignore the sign because I'm going to square it. So it's 3 squared on this side, 9 over here. This makes my factoring easy to x minus 3 quantity squared equals negative 27. Now, I might have skipped some steps here, so I'm just going to go a little slower. You take the square root of both sides, okay? And when you take the square root of both sides, you have x is equal to, I'm going to have the square root of that, but I'm going to add the 3. So that's going to be 3 plus or minus. What is the, and I actually encourage y'all to remember to write this so that you would see that there's a negative underneath there, which means there's going to be an I in my answer. And the square root of 27 is 3 square roots of 3. So it's 3i square roots of 3. And then you can't forget that negative 6. So those are all the answers of that. If x plus 6 equals 0, then we subtract the 6 from both sides. Okay, b, 9x to the 4th plus 12x squared plus 4. That's the quadratic like that I talked about. This exponent times 2 is equal to that exponent. This is quadratic like, so you can find the factors of 9 and the factors of 4 and figure out what gives you 12. Or you can recognize this as a PST, because that's a perfect square and that's a perfect square. And so it's going to factor to a plus b quantity squared. So I'm going to take the square root of 9x to the 4th. That's 3x squared. And I'm going to take the sign of my second term, which is plus. That might be different in your handout if you printed. So just make sure you got a plus up there. And then square root of 4 is 2. And remember, I talked about checking it. 2 times 3 is 6 times 2 is 12, which is my middle term. Okay? Then we take the square root of both sides. Square root of the left side is 3x squared plus 2. Square root of the right side is 0. Square root of 0 is 0. So then I'm going to subtract 2. And I don't want to take the square root until I get rid of that 3. So x squared equals negative 2/3. So when you take the square root of both sides, again, there's a negative under that radical. You're going to have an I in your answer. And y'all, I would have to rationalize it. Most of y'all have calculators that do that, but I can go ahead and extend this and multiply it by 3 over 3, which hopefully lets you understand why the answer is x equals plus or minus. Square root of 3 times 3 leaves me with a 3 on the bottom. Square root of 2 times 3 leaves me with the square root of 6 on top. Because there's a negative right there, there's an I in my answer. Okay? So, 2 more examples, and we're done. 3x cubed plus 7x squared minus 12x equals 28. First and foremost, from the very beginning, you got to have 0 on one side. So I've got to subtract that 28. And this time, I'm going to group them, 2 and 2. Okay? So I'm looking for what's in common with the first 2 terms, and that, of course, is x squared. Take an x squared out of 3x cubed, and you're left with 3x plus 7. I've told you that you always carry this sign down, so I'm going to have a minus. And what's in common between 12x and 28 is 4. Leaving you with, and I told you to write 3x plus 7, so I'm going to write 3x plus 7, and then I'm going to check it. Negative 4 times 3x is negative 12x. Negative 4 times 7 is negative 28. So I know I've factored correctly. And as I mentioned, this is my common factor that's going to come out. So that's going to be 3x plus 7. And I hope you can see what's left is x squared minus 4. Okay, those are equal to 0. And depending, if the directions say factor completely, you're not done. And I said, whenever you get to think where you think you're done factoring, in Algebra 2, you got to look and see if you can go further. This can go further because that's the difference of 2 squares. So I'm going to have 3x plus 7, x minus 2, x plus 2. Order does not matter, y'all. I set each factor equal to 0. 3x plus 7 equals 0, x plus 2 equals 0, and x minus 2 equals 0, which means I'm going to subtract 7 and divide by 3. So I'm going to have x equals negative 7/3, negative 2, or positive 2. And that's what we have. All right, last example. Y'all, be careful. A lot of people want to divide by x, and if you do that, you lose one of your roots. So do not do that. You need to set it equal to 0. So I'm going to subtract 18x from both sides. Then I'm going to look for my GCF, and my GCF in this case is 2x. So when I look at 2x, and you know, one of the things, y'all, you look at this and go, well, that's not 2 perfect squares, so I don't know what to do. But you might recognize it if you take out a GCF. So if I take out my 2x, I'm left with 16x to the 4th minus 9. So that is the difference of 2 squares. 16x to the 4th is a perfect square. 9 is a perfect square. So I'm going to have 2x times 4x squared. That's the square root of 16x to the 4th. And then one is minus 3 and the other is plus 3. And you set each factor equal to 0. Now, I kind of skipped a step here too. The first one, if you divide by 2, then you can see it easily that x is 0. But here, when you divide by 4, y'all, okay, if I divide both sides by 4, I would have x squared equals 3/4 and x squared equals negative 3/4. So when I take the square root of both sides, 2x x equals 0, so the square root of that is just x equals 0. When I take the square root of this, I get plus or minus 3/2. Or square root of 3 over 2. And the only difference between this one is it's going to be plus or minus the square root of 3 over 2i because of that negative. And that is your answer. So that's all there is. Just making sure you remember to distinguish between if it starts with an expression, it ends with an expression. If it starts with an equation, it ends with an equation. I hope y'all like that. Thank you so much for watching, and y'all have a great day.